Hello and good afternoon, ladies and gentlemen. Welcome to our webinar on the importance of 3D maps for 5G deployment. Today, we have the pleasure of hosting a distinguished expert who will provide valuable insights into this critical topic. Our speaker, Ms. Sita Gurung, a renowned rfMap specialist with over 15 years of experience in this field. She has worked with several leading telecom companies as client and is currently the product head for RF maps at Lepton Software. We are fortunate to have such an experienced and knowledgeable speaker with us today. I'm sure this webinar will be informative and insightful. So without any further ado, let me invite her to begin with the presentation. Over to you, Sita.
Thank you, Nancy. Thank you for such a nice introduction. Hello, everyone, and a very warm welcome. So let me just see. Okay, I believe we can start the session now. Nancy, could you please check the attendees? If we have sufficient attendees, we can start the session.
We can start the session, please.
Sure. Thank you, Nancy. So let me just open my presentation. Nancy, could you please confirm if it is visible? I have shared my screen now, the PPT.
Yeah, it's visible.
All right. Thank you. Thank you, Nancy. So today we will talk about 3D maps, which is a key component of our product rfMap, and why these maps are essential for your 5G network deployment. Okay. Okay. Even before that, Nancy, can you hear me?
No, Sita, I can't hear you.
Can you hear me now?
Yeah, Sita, I can hear you now.
Okay, are we good to go?
Yeah.
All right, thank you. I'm really very sorry. So once again, hello everyone, and welcome to this session. And I am really very thankful for all of you to join this session. Let's start today's topic. So today we are going to talk about 3D maps, which is a key component for our product rfMap, and why 3D maps are essential for 5G network deployment. Okay, even before we start talking about 3D maps, let's see what is rfMap, what is its objective, the solution that we are offering, as well as the impact. I'm so sorry, Nancy, could you please mute yourself? I'm getting this background noise.
Yeah, sure.
Thank you. So yeah, objective of this rfMap. Now, rfMap, it's basically a digital map data product. It's the input that every telco requires. And the actual objective is basically to help telcos to check the feasibility, to do the planning, as well as for the optimization of the existing network. Now, the solution, what are the solutions that we are offering? Very high quality and precise geographic data that will be ingested in your RF planning tool, whatever RF planning tool that you are using. And what could be the impact? Faster and more accurate RF planning. And obviously, if you are getting a very precise input digital maps, the RF planning will be faster and would be more accurate. And ultimately, it will result to cost saving. That's all about objective solution and impact of rfMap. Now, I would like to talk about few USPs of rfMap. First of all, global coverage. So we have been into this business from past 2 decades, I would say, and we have been generating and collecting these information across world. So we have captured almost all countries and we have readily available data set in our archive. That's why we are saying global coverage. That's what we have. Maps available from 1 meter to 100-meter resolution, which includes 3D map. So the resolution or the quality of the data set, it basically varies from 1 meter to 5 to 10 to 50 to 100 meter. Mapped more than 150 plus countries and 1500 plus cities. So as you can see, we have almost covered 80% of countries across world. And within those 150 countries, we have somewhere around 1500 plus cities. Compatible with all planning tools. What does it mean? Our data set, our rfMap product is compatible with all the planning tools, and not only planning tools, it is actually compatible with all the drive test tools, all the industry's standard GIS format. So you can name the planning tool, you can name the format that you want to have. We can simply provide our data set rfMap in that particular format. Recognized industry leader and preferred vendor for leading equipment provider. So we are basically a recognized rfMap provider, as well as we are the preferred vendor for many equipment providers. We are in registered vendor list of Ericsson, Nokia, Huawei, ZTE, and not only these companies, we have been supplying maps to all the OEMs, all the SIs, and all the operators. More than 90% of networks in India have been launched using rfMap by Lepton. So we, being an Indian entity, we have our headquarters here in India, in Delhi NCR. And as I have mentioned, we have been creating these data sets from past 2 decades. In fact, to be very precise, 29 years. We have completed 29 years, and we actually have started with this product only. And that's the result and outcome. For Indian territory, 90% of network by all the operators has been rolled out on our data set, on our rfMap. Let's talk about component of rfMap. Now, depending upon your planning needs, depending upon the technology you are using, or maybe the technology that you want to deploy, we have 3 different solutions within rfMap. Okay, the very popular and the demanding component is 3D map, which we are going to discuss today. The second option is 2.5D map. Now again, 2.5D is also available for 5G network planning, and we have exclusively designed this, I would say, hybrid product 2.5D map for 5G network deployment. I would say the location or the AY may differ for this particular product. For 2.5D, you can basically go with suburb area or outskirt area. And the last one is 2D maps. 2D maps are the traditional maps that we have been creating for the customers who basically have started with, let's say, 1G, 2G, 3G till 4G. We have been using 2D maps. And within 2D maps, we have various resolutions, various quality of the data set, starting from 5 meter to 50 to 100 meter. So these are the 3 components of rfMap. And depending upon the network deployment, let's say if you are going with 5G network deployment, you can choose either 3D or 2.5D maps. And for 4G and beyond that, you can go with 2D maps. Now let's deep dive into 3D maps. So as we all know, the world is rapidly moving toward 5G, and every operator is actually planning for their 5G network rollouts, right? And for 5G network, we all are very familiar with the fact that the frequencies of 5Gs are very high, and obviously higher frequencies with very short range. And a shorter range of frequency will demand operators to install large number of towers or site or cells. So obviously the RF planning team, who will be responsible for this activity, who will be responsible for the planning activity, they will have to plan for the new towers, or I would say numerous towers, to be placed selectively and strategically. That is very important, right? And as we all know, these short range frequency can be disrupted by smallest obstructions. The traditional 2D maps that we have been using for our technologies till 4G will not be sufficient enough to cater 5G needs. And therefore, very accurate 3D maps are key here. And these 3D maps should basically give you the precise information about all the obstruction in the ground, be it buildings, be it flyover, be it bridge, or maybe even for the trees. Okay. Now, let's see what all data layers are available in 3D maps. So 3D maps exclusively designed digital map for 5G network planning, multi-stereo satellite imagery derived at 1 meter resolution. Let's talk about data layers. So there are 7 different data layers that we offer to our customer, starting with the very first layer, which is 3D building. Building footprint with rooftops with 1 to 2 meter of accuracy in height. Okay. So when I say 3D buildings or building footprint and rooftop, we basically create polygons for buildings, and it's not only very simple polygon, we basically create detailed multi-polygons for a building. So that's why you are going to get the information about footprint as well as rooftop structures. Okay, that's the very first layer. Second layer is 3D vegetation. Now we capture a vegetation or forest or green in stacked polygon format. Okay, which means you are actually going to get 3D vegetation in stacked polygon format with respective height information. And what is the reason to create stacked polygon for vegetation is to replicate the irregular shapes, or the difference of height that is there on the actual ground. So we are basically trying to replicate the exact data set on our map as well. So that's second layer. The fourth layer is 4D bridge. So I mean, you might be wondering why 4D out of 3D. We have been talking about 3D data set, now why 4D? So 4D is because we are actually integrating 4 different attributes for these elevated structures. So when I say 4D bridge, it will have the height information of that particular structure from ground. It will have the length information for the entire structure. It will have the width information for that structure. Moreover, even the depth or the thickness of that structure that is being used to create that particular elevated structure. So we will capture all these 4 attributes and will provide this information with 4D bridge. Fourth layer, DTM, digital terrain model, which will have the information about height from sea level, and it's basically bare earth surface height, which means if you remove all the buildings and greens from the earth surface, that's the height information that you are getting. And in telecom industry, the very popular term that we use is, with DTM you are going to get MSL value. Okay. Clutter height, the fifth layer, clutter height, or the popular term that we use for clutter height is DSM. You can call it DSM as well. So with clutter height, you are going to get the height information for all the objects that are lying on the Earth's surface, be it buildings, be it road networks, be it, let's say, 4D bridges, or be it vegetation. The only difference is both clutter height and DTM layer will be available in raster grid format. Okay, so it's not the vector data set, but raster image or raster grid files. Both these layers will be available in raster grid files. Sixth layer is linear vector. And this is the first 2D layer which is available in this package. When I say 2D layer, it means we are not integrating any height information in this particular layer. So linear vector will have the information about various categories of road network, water bodies, railway network, administrative boundaries, and moreover, you will also get the text information or places name or major landmark POI information in this layer. So that's linear vector. And the very last layer that is available in 3D map is clutter. So clutter is very basic data requirement for RF planners. Clutter, or you can also call it as land use, land cover data set, which will give you the information about various settlement patterns like dense urban, medium urban, low urban, or even for the land cover features as well, like water bodies, rivers, forest, dense forest, medium forest, or let's say open area or park. So you will get all these information in clutter dataset. Now again, clutter dataset will be available in raster grid format, or you can say in character grid format. Okay, so these are the 7 different data layers that are available in our offering, which is 3D map. Now, why 3D maps by Lepton Software should be of your choice? Why these 3D maps for Lepton? First of all, superior quality. So it's not just that we are, repeating to go with 3D maps by Lepton. We are actually creating very high quality 3D maps. And the pointers maybe that I have or that I can discuss, basis on which we can actually produce these high quality maps are: first, high resolution multi-stereo imagery produce 3D maps, which means the input that we are using, the satellite imagery, right? So to create any digital maps, we would require satellite imagery. And for 3D maps specifically, we need to have stereo satellite imagery. The traditional approach to create 3D map is to use stereo satellite imagery, maybe single stereo satellite imagery. That's what every map company is using. But for us, we are going with multiple stereo satellite imagery, collection of different satellite imagery or collection of different stereo satellite imagery. And that's why the level of accuracy that we can achieve is below 1 meter. And that's why we love to call our data set as sub-meter accurate data set. Okay? Most precise data with sub-meter accuracy. The reason why we call this data set sub-meter accurate data set, I have already mentioned. The even the resolution that the resolution of the satellite imagery that we are using to prepare this data set will range from, let's say, 0.3 to 0.4 to 0.5 to 1 meter. These are the various resolution of stereo satellite imagery that we are using to create these 7 different data layers. Detailed individual building representation in multi-polygon format with all super and substructures. So as I have mentioned, we basically create a single building in multiple polygons. So we represent a single building in multiple polygon format. Why? In actual scenario, you can see, right, your building will not be a single block of 4 walls. It will have the irregularities. It will have some sort of, superstructure lying on the rooftop. We at Lepton try to capture each and every details of these buildings, even the corner, even the staircase structures. We capture all these information in our building data set. That's why That's the reason multiple polygon will be available for a single building in our dataset. Vegetation in stacked polygon format to capture real earth representation. As I have mentioned in my previous slide, for vegetation layer, we represent our vegetation dataset in stacked polygon, or you can also call it contour polygon format. Reason, so that we can actually give the customer the actual representation of these forest or green patches that is there on the earth. Okay, in fact, you can refer the images that I have kept here. You can see the level of details captured in these images. We have 3 different images for buildings. You can see that all the superstructures has been captured. Even for vegetation, you can clearly see the different stacked or different contour level of the vegetation. Now, what are the value additions? So apart from the level of detailed information that we are capturing, we have our own in-house production team. So we, having our headquarters here in India, we have very competitive costing for our data set. We have prompt technical support. We have extensive exposure of working in different geographies. We have our own in-house R&D team. So you can see we have a house of, I would say, power-packed engineers who are responsible for these data sets. Nearly 24/7 support. So since we basically have to cater to different regions for our different customers, we worked in shifts. That's why we are, stating that we basically provide 24/7 support. Extensive experience of working worldwide. We have created data set for 150 plus countries. So we have the knowledge of the clutter variation in each and every geography. Okay, we have that familiarity working with different operators or different telcos, right? Strong in-house RF team and knowledge. So apart from our engineers, our remote sensing and GIS engineers, we do have our own RF team with highly skilled team and with all the knowledge. They can actually validate our data set. So before delivering these maps to our customer, our own RF team will first validate these data set, and that's the reason the customer can actually blindly rely on our data sets. So it will obviously save time at the customer end. I actually have few case studies here. So as I have mentioned, we have been working with all telcos and we have been providing these data sets to everyone, and we have worked with customers across globe. So I actually have kept few of the case studies that we have, in which we have supplied these maps. The very first one that I want to highlight is for one of the national operator in US. For this particular customer, we basically have provided combination of 3D and 2.5D data set for their 5G network deployment, obviously. And as you can see, we have supplied almost 7 to 8 different data layers. In terms of coverage, we have provided 1 meter data set for 5K square kilometer, and the medium resolution 5 meter data set, we have covered 11,000 square kilometer. The second use case that we have, case study that we have is for the operator in US again. It was basically the 3D data set. So 3D data along with 3D vegetation, clutter height, or you can also call it DSM, DTM. So all these layers were supplied to this particular customer. And in fact, the quantity, the volume is much, much bigger than the previous one. So for this particular project, we actually have created 3D data set for almost 25,000 square kilometer. And in terms of 2.5D or in terms of clutter data set, we have created clutter height dataset for 348K square kilometer area. The third case study that I have is for the Indian operator BSNL. They are the national operator here in India, and we actually have worked with Nokia for this case. This particular project was for their 2G, 3G, and 4G network expansion in Indian territory. And with Nokia, we actually have supplied 2D, 3D, and I would say medium resolution 2D map for West and South zone. So all the data layers for 3D map, all the data layers for 2D map were supplied. And the table here is actually for the various data set that we have supplied for this particular project. The fourth case study that I have is for Reliance Jio, the biggest Indian operator here in India in terms of their coverage or in terms of their subscriber. Reliance Jio is the biggest one, and we can proudly state that we are the selected vendor for them for their 5G network deployment, and we are responsible to supply 3D as well as 2D data set for their 5G network deployment. And this is an ongoing project. We haven't completed it yet. We have a target till September this year to complete this project. This particular project is for supply of 2D maps for 800 plus cities, and we have another set of maybe 1500 cities in second phase. After we complete this particular project, we are going to start with the second phase of 3D map production for another set of 1500 plus cities for geo only. So these are the case studies. Though we have our customer across globe, we have worked with various telcos, not only operators, obviously. We have worked with all the telcos, all the tower companies, and I have basically selected few of the case studies for this session today. And yeah, that's all for today's session, and all about 3D maps and why it is an integral part of 5G network deployment. We probably now take a few more minutes to quickly check the queries that we might have received. Over to you, Nancy. Do you want to check if we have got any queries?
Yeah, sure, Sita. Thank you so much for an insightful session. We are now open to take up any questions you all might have. Is there any question anyone have?
It seems we don't have any queries. Nancy, probably we can wait for another maybe 2-3 minutes.
Sure.
Else, we are open to answer your query. You can reach us anytime if we miss addressing any queries.
Yeah, so there's a question, Sita. Could you please take a look?
Is there a certification? I'm really sorry if I have understood correctly. Certification in terms of what, if I may ask? It's not very clear, this query. About this training. Yes, probably our marketing team will reach you regarding this session. So they will be in touch with you, and maybe you can take up your certification thing with my marketing team. Any queries related to data set related to 3D map and why you need 3D maps for your 5G network deployment, or what are the key factors for 3D maps.
There's also one more question, Sita. Please take a look.
Where do you get your map data and imagery from? Okay. So in terms of imagery, we basically have various sources. So imagery is integral part as an input. So we can refer to imagery provider like Maxar. We have European imagery provider like Spot. We have, Japanese imagery provider. So depending upon the project, depending upon the commercial and the quality of the data set, we basically refer satellite imagery. But our preference is always Maxar satellite imagery. And in terms of map data set, as I have mentioned, we are the OEM for these map data set, and we have our own in-house team who can produce these maps, who can create these maps. I hope I have answered your query.
Yeah, I guess that's all for all the. No, I guess there's one more question.
Yeah, hold on. Can we use 3D map for 4G network planning? Definitely. Why not? I mean, you can definitely use 3D maps for your 4G network planning as well. I mean, depending upon the frequency that you are using, the bands that you are consuming for your 4G network, you can definitely use 3D maps. Landscape change, boundary change. How do you ensure your data is always updated and accurate? How frequently do you update? Very good question. So, in terms of updation, in terms of changes, definitely, you being an operator, you need to basically have an overview about the changes that has happened. So for us, for Lepton, we basically have AMC option. Within AMC, our customer can actually opt for the frequency of data updation, whether they wanted to go with half yearly upgrade or quarterly upgrade. So we can discuss with our customer, and depending upon the mutual agreement that we conclude, we basically can supply the updates to our customer.
Okay, so thank you, Sita. That's all the questions we have. Thank you so much for answering. And thank you all for your time and participation in this webinar today. So, and we are very glad to have you on board. And before signing off for today, I would like to inform you all that we have another webinar planned as a part of our telecom webinar series. And it's on Neo 360, Lepton's Geo Analytics platform for telcos. You can also watch out our LinkedIn page for registrations and other details. Thank you so much. Thank you, everyone.
So, Nancy, probably we might have missed few of the queries. Maybe you can collect
Oh,
these questions
yes,
and
of
we
course.
can answer them over the mail or over the call.
Yeah, sure.
Okay. Thank you, Nancy, and thank you, everyone. Have a nice day.
Yeah, thank you.